Hello Internet, my name is Quinn and this is Blondihacks. I've often said that every hobby machinist goes through phases. In the same way that every 12-year-old wants to play the guitar for 2 weeks, every hobby machinist at some point wants to own a D-bit grinder and a pantograph and a shaper. So let's go. Periodically I've been doing live stream chats with the Hamilton Model Engineering Club out there in Ontario, and I made the terrible mistake of mentioning in one of those that if I ever saw a shaper, I might be hard-pressed to say no to it. And, well, then a shaper appeared courtesy of the Hamilton Model Engineering Club, and I couldn't really say no to it. Thanks to the fine folks at Manitoulin Transport, the crate and associated stand arrived unscathed, all held together with a metric ton of Robertson screws, because this is Canada and we're not monsters. If this was a just world, Phillips screws would be classified as a war crime. Some intrepid previous owner of this machine built this quite sturdy stand for it, all welded 2-inch tubing. The club offered me this with the machine, and I said, yeah, why not? I'm going to have to put it on something, so I'll give this a try. It's a little bit low for me, so I'll probably end up either blocking this up or I might modify the stand. I don't know, we'll see, but for now, it'll get me going. All right, let's get the screws out of the rest of this thing and get it open. I cannot stress how many screws were in this thing. It's so many screws. Oh, look at that. Huh, box is empty. Well, good video everyone, thanks for coming. I'm just kidding, of course there's a shaper in here. Look at that. This is a 1960-ish, I think, Atlas 7B. I believe it's 1960-ish because they made these machines from 1937 to 1961. This is a 7B, which was the final model of it, and it's a fairly high serial number, so I'm guessing about 1960. If you've never seen a shaper, they were a single-point cutting machine for creating flat surfaces. In the early days of machine shop work, machine tools were all single-point cutters because the cutting geometry is very easy to create, and the machine doesn't have to be as rigid if you've only got a single-point cutter. Vertical milling machines, like everybody has nowadays, are a relatively recent invention, partly because of the rigidity they require, and partly because they require the ability to manufacture end mills. End mills are very complicated and difficult things to make, and for the first 100 years or so, we didn't have the ability to do that. The two main machines then that created flat surfaces before vertical milling machines were shapers and planers. One of them moves the work and one of them moves the cutter. Similar to how lathes move the work and the cutter remains still, a planer is the same idea. It slides the work back and forth on a huge table underneath the cutter, and a shaper is the opposite. The work remains stationary and the cutter moves back and forth over it. So why don't we use them anymore? Well, to quote the old machinist joke, you can make anything on a shaper except money. Yeah, they're not fast. That is the main disadvantage to a shaper, is they are pretty slow at what they do, but they are charismatic and fun, and they can do a few neat tricks that even some modern machine tools really struggle to do. Packed in all around it were all of the various bits that go with it. This, of course, is the tool head with the clapper box. That's the tool post. It's a lantern-style tool post. Here's a couple of random tool holders in here that may or may not be for this machine, and some shop-made ones, and I believe that's an actual Atlas tool holder there. And actually this really cool L-shaped tool holder for doing internal shaping, like cutting keyways, that kind of thing. It's also shop-made, looks like. Pretty cool. And the all-important crank, without which you cannot operate anything on this machine, and of course a bunch of bolts and miscellaneous hardware. Then the motor mounting frame, also important. Nice that that's there, the original one. The tool post, as I said, this is a lantern-style tool post. Machine tools used to all have these. They're very simple and straightforward, not very rigid, that's why they don't use them anymore. But for this kind of machine, it's just fine. And then the tool holder itself goes up in there, and then a single bolt locks it all together. Then it's all sitting on the clapper box, which claps up and down, or in and out as it were. This is like a mechanical one-way valve. It allows the tool to retract off of the work automatically as the shaper pulls back and slides over for the next cut. Otherwise the cutter would have to drag itself through uncut work as the crossfeed is feeding over during the backstroke. Now it's time to lift this thing off the pallet. I'm going to install the tool head now to do that. Not that I'm going to lift it from the tool head, of course, but the way the main casting on this thing is, it's a little bit, I was a little bit concerned that the straps might slip off, so the tool head will be a little bit of insurance against that happening. Now it's time for the inevitable engine hoist. I don't know what home hobby shops did before the invention of these things. Step one with an engine hoist is always get the thing you want to lift high enough to clear the legs on the engine hoist, because of course these things aren't really made for lifting pallets, and pallets are always too low for them. So there's always some sort of dance involving jacks and pry bars and blocks of wood to get the pallet up off the floor high enough. Engine hoists are really only designed for pulling the ill-conceived big block swap out of your MGB after you grenade the differential, so the legs are always sort of in the way for this kind of stuff. If you have to go up very high, like in this case, then go a little at a time, side to side, so you don't have it tilted too far at any one time. The machine is bolted to the pallet still, so it's not going to slide off while I do that. And now I can get my lifting straps rigged up. I'm going underneath the main casting everywhere here. I'm not lifting on the ways or lifting on anything that moves. I do have the manual for this machine. I downloaded it from vintagemachinery.org. Thank you very much, Keith Rucker, for that. Unfortunately, the manual does not list proper lifting instructions. I've never seen a machine tool manual that doesn't tell you how to lift it, but this one does not. However, this is how the club told me they do it, so who am I to argue? And it seems like the logical choice. All of the weight here is lifting only on the main frame casting, so it seems like the obvious thing to do. Just double checking that those straps are in good places. They're not going to slide off. They're not catching on any lubrication pipes or wiring boxes or anything that you didn't see. And here we go. Let's get this thing in the air. It's not really that heavy. I think it's about 350 pounds, this machine. But, you know, no matter how many times I do this, I still get nervous every time. There's something about having something valuable and heavy hanging in the air that just makes me nervous every time. Basic lifting safety applies. Use actual lifting straps, not ratchet straps, and don't put anything you care about underneath the load at any time. With the hoist still holding most of the weight, I can shove it around and get some punches in there to line up the bolt holes, and then we can lower it into place. I did have to make a quick run to the hardware store and get some very, very long bolts because the bolt holes in this table go all the way through the 2-inch tubing, and of course they have to go through 3/4 inch plywood and the base of the machine. So it took a lot of bolt to do all of that. Next thing I want to do is go through the entire lubrication procedure in the manual. This machine has 35 lubrication points, which sounds like a lot, but it's really not as much as it sounds like because most of them you only do them very occasionally. There's only 2 or 3 things you're supposed to lubricate every single time you use the machine. I grew up fixing tractors, so these giant lubrication charts are not at all intimidating to me. They're never as bad as they first look. Shout out again to Keith Rucker and vintagemachinery.org. You know, his website is such an incredible resource for old machine tools. If it wasn't for him, I don't know where some of these manuals would ever be found, and you really do need the manuals for these machines. A lot of these lubrication points that I'm hitting now, you would never find if you didn't have the manual. Some of them are obvious, but at least 20 or 30% of them you'd never find. The manual also tells you whether you should use oil or grease in each spot, which is important and not always obvious. This guy wants grease on the main bowl gear, but a lot of shapers use oil on that. Lots of lathes use grease on the change gears, some of them use oil, so you just never know. I would say when in doubt, use oil. Oil is usually safer and isn't going to collect dirt and chips and so on, but the manual will tell you for sure. And just because you see a Zerk fitting, don't assume it's grease. That is a modern disease. You find a lot of these machines that are all pumped full of grease just because there happen to be Zerk fittings on the oil points. There are Zerk oilers as well. I don't happen to own one, so I just take the Zerk fitting off and shoot some oil in there. But Zerk oilers are a thing. Don't be a grease monkey and go pumping grease into everything you see. I found a tiny bit of rust on one spot on one way, which is pretty amazing considering this machine is 65 years old. It's in incredible condition, this whole thing. It's been very well cared for its entire life. That was really the only rust that I found. I inspected all of the ways, re-lubricated everything. I'm also going over all of the precision surfaces with precision ground flat stones. If you've not seen these before, these are not just regular India stones. They've been ground perfectly flat with a diamond wheel on a surface grinder, so they will take off dings and high spots on precision surfaces without scratching the surface or creating low spots. Found one gib adjuster that was loose, so I snugged that up. And I did find a couple of other bolts here and there that were loose. I went through and checked them all just in case. It's an old machine after all. The tool gib was weirdly tight. It was locked up completely. Maybe they did that for transportation. So I loosened that up, oiled everything up, and then readjusted the gib on that. That is running nice and smoothly now. The only way damage that I found anywhere was this one spot on the RAM way, which is not at all surprising because the RAM, of course, does 90% of the work on this machine. So I figured, well, there's a little bit of damage there. I should take them all apart and give a little inspection here. Luckily, it's a very simple machine. These are just box ways. Simple cap on top holds it down. Brass shim sets the clearance on that. Very simple machine. On the other side, actually, it looks really good. There's some marks there, but they're not scratches. Nothing you can feel with your fingernail. So that side, frankly, looks pretty much perfect. That's a relief. Same with the underside of the way cover. That also looks really, really good. I guess this is actually the top of the way itself rather than the way cover. Not sure what all these parts would be called. So soak everything down in oil. This RAM way, you really can't over oil. Like it needs to be swimming in oil all the time. So I'm not taking any chances with that. Taking a closer look at the other side, you can see the damage there. It goes about halfway down, which makes sense. That's where the RAM spends most of its life moving. So it looks like some chips or something got in there and stayed in there for a while, scratched it up, but it's not too bad. The way is certainly functional. Back to the other side though for a second, things get weird. See this little oiler here? It lines up with this little half circle cutout in the way, and that allows oil to get down underneath the RAM way to lubricate the bottom. There's even a little cutout in the shim for it. So that all makes sense. Same oiler on the other side, but look at this. There's no little half circle cutout. The little cutout in the shim is there, but there's no cutout in the gib next to where that oiler comes out. So that oil has nowhere to go. But wait a minute. What's this cutout down here? That looks like the same little oil passage, but it's in the wrong place. I loosened up the gib adjusters and I fished the gib out of there, and it's a rectangular gib, which means it can be flipped over. You can see the oil passage goes all the way through the gib again so the oil can get to the underside of the RAM. And if I clean that up and flip it over like so, everything still lines up, the little indentations on the outside of the gib, but now that little oil passage lines up with the gap in the shim, and sure enough, also lines up with the little oil cup on the cover. So that is clearly how that gib is supposed to be. It was installed upside down at some point. I don't think that has anything to do with the damage on the way on this side, because that oiler is, as I said, for the underside of the way, not for the top surface where the damage is. But since there is a misalignment there, I want to make sure that the underside of the RAM has been getting lubricated properly, and I've got it all apart anyway. Might as well check it now. The RAM is too heavy for me to lift off, but I can prop it up with a little kickstand. No, I'm not going to stick my hand in there, but I can look in there with some light and inspect. And the good news is the underside of these ways look really, really good. No scratches, no gouges, plenty of oil. There was just tons of oil in there, so the oil was getting down there even though the passage was misaligned, so no harm done. Just kind of funny that someone put that in upside down at some point in this machine's 65-year life. Speaking of old-timey lubrication systems, here's another one on this side of the machine. There is, in the center of the step pulley that drives the main mechanism, we have a grease cup. This is just what it sounds like. It's a threaded cup that you fill with grease. And the idea is periodically you give that cap a little bit of a twist, tighten it in a little bit periodically, and it'll push some of the grease from the inside of the cup into the mechanism. That cup was empty, so I filled it up with more grease and then snugged it up a little bit. I think grease cups are a really neat idea. Those are a very old idea. They used those on some of the earliest of steam engines, so that's a 200-year-old idea. Still works great. This drive belt, unfortunately, has seen better days, a little tattered. I do have a few belts in my drawer, but unfortunately, I couldn't be that lucky, and none of them are the right size, so I'll be replacing that at some point pretty soon, but for now, the tatty old one is going back on, and it'll serve me just fine for a little while yet. If that belt breaks, nothing bad happens, the machine just stops. But we want this machine to go, so let's see about getting the motor on it. This is the original cast Atlas motor bracket. This machine is from the era when power tools were bring your own motor. Sometimes they had an optional motor that you could buy with the machine. There was an Atlas optional motor, but a lot of times people bought them without because in the early days of electrification, electric motors were very, very expensive and could easily double the price of a machine. The shop that my dad and I spent a lot of time in, my grandpa's farm shop, he had one electric motor and he moved it around between all of his power tools because he had a drill press and a table saw and lots of power tools, but the electric motor was just too expensive, so he only had one, and he had his own little carriage system built of 2x4s that he moved the motor around with. This is not the original motor from this machine, of course. It's somewhere along the way acquired this one. This is a Canadian General Electric, 1725 RPM, quarter horsepower. It's actually a little bit slower than the manual says it's supposed to be, but that's okay. And the manual actually suggests between 1/3 and 1/2 horsepower for this machine, so 1/4 might be a little low. But spoiler alert, it is definitely not too low. I thought about maybe I should get a bigger motor, but then I saw this machine run, and it does not need a bigger motor. A little bit of creative washer archaeology was required to figure out how they had this thing installed, because none of the bolt holes line up, so there's some bolt hole adjacent clamping happening in order to get the belt pulley to line up on the motor. It's also quite important on a shaper that the motor spin the right direction, so the countershaft pulley has an arrow on it that tells you which way that's supposed to spin. The reason is that the motion of the ram is actually asymmetrical. It moves faster on the return stroke than it does on the cutting stroke in order to, be more efficient effectively. On a shaper this small, the effect is actually pretty subtle. It's hard to tell that it's moving faster on the return stroke, but technically it is. So you want to verify the direction the motor is spinning and change the wiring if it's going the wrong way. Now, if I've done all this right, then the belt should be loose now, but then when you raise the clutch arm, it tightens both the drive belt and the countershaft belt. All right, let's kick the tires and light the fires. Whoa, look at that. Okay. So the countershaft is spinning, even though the clutch is out, but the machine is not running, which is maybe okay. More on that in a bit. Let's see if it chooches. Here goes nothing. Whoa, oh, look at that. It's shaping. It's a shaper. It's shaping. It's doing the thing. Look at that. That's pretty cool. I'm out of frame, but I had a huge smile on my face when that thing started moving. Now, I will say I did have quite a bit of trouble with the clutch mechanism. You can see how loose I have the motor drive belt right now, and that's because if I have it any tighter than that, then it won't declutch. You can see even with the V-belt just barely touching the motor pulley, it still spins the countershaft when declutched. So I need to play with this some more. It works okay right now, but I don't trust the clutch. I'm not going to put my hand in there when the motor is powered up. If I need to adjust anything on the machine or on the work, I shut the motor off completely because I don't think I can trust this clutch. It does have a brake though, which is nice. When you push down on the clutch, there's a little wedge that gets driven into the countershaft pulley to stop the ram. That's kind of a nice feature. Yeah, that clutch is very finicky. I'm not very happy with how it's working right now, but I'll be fiddling with that some more later, I think. I might have to grease the belt a little bit to get it to slip the way it's supposed to. I guess modern V-belts are a lot better than 1960s ones were. Well, you know it's serious when the dial indicators come out. Let's see how well aligned the table is with the ram. The answer is not very. The front of that table is about 10 thousandths low, so that's not great. Luckily, this turns out to be an easy fix. I didn't have the knee all the way down for starters, so it wasn't pushing fully down on the support foot in the front of the knee. Also, I didn't have the knee locks tight. There's 8 big bolts on the back of the knee way that all have to be tight at all times, except when adjusting the height of the knee. The manual is very, very clear about this, that you shouldn't ever take a cut with those bolts loose or you'll very badly damage something. But with those 2 changes now, it's within 0.5 thousandths, so bully, can't complain about that at all. Now let's talk about vices. I'm going to need something. The club threw in this shop-made toolmaker's vise. Someone has made this guy. It's quite nicely made. It's not a shaper vise exactly, but I do need something, and this might work. I also found in my drawer this Wilton vise. I don't know if it's a drill press vise or a mill vise. I think it's probably a drill press vise, but it's kind of a nice size for this machine, so it might work. Now, I won't be able to clamp it down in this orientation. The clamping systems that I have won't work. It's too close to the T-slot, so I'll have to make something to clamp it in this position. However, I can rotate it 90 degrees and clamp it this way. And this is apparently how a lot of people run their shaper vices. I know that Adam Booth runs all of his shaper vices sideways, and I know that some of the club members that have shapers do this as well, so this is probably what I'll try. It makes sense because generally you want to cut work long ways on the shaper because it's more efficient that way. By cutting long ways, the shaper is spending most of its time making chips and less time cross-feeding. Every stroke and every cross-feed action has some overhead, some mechanical work that has to be done that costs time. So you want it to have as few strokes as possible across the surface, and thus you want the strokes to be as long as possible. You get it. Anyway, I'm ready for a tool bit, so time to grind some tools. One of the advantages of a shaper is that the tool geometry of it is very, very simple, as I said at the top of the show. Single point cutter. So I grabbed a piece of high-speed steel, and the instruction manual has some sample tool geometries, so I'm grinding a basic roughing tool. Looks like this. Simple 20-degree angle on each side, rounded nose, about a 10-degree back rake. I've only got about a 5-degree rake on mine because the tool holder has a built-in rake to it. I've also got a finishing tool here that came with the machine. I'll talk more about that in a bit. So I trimmed in the vise this way, and I'm just checking the crossfeed now. The manual crossfeed works extremely well. It's actually really, really smooth and nice. Everything's of course been oiled up and Gibbs adjusted and so on. I wanted to see if I could get the power crossfeed working. So you set the eccentric for the feed distance, and then there's a little switch that you engage. And then when the clutch is running on every backstroke, there's a little ratcheting mechanism that's supposed to advance the horizontal position of the knee. Unfortunately, it's not working. You can see the knee crank is just wobbling back and forth, so the little ratchet in there is not ratcheting. I'm going to have to probably take that apart and take a look at it. It's a very simple mechanism. There can't be all that much wrong with it, but I want to make some chips in this video, so I'll just feed manually for now, and we'll look at that crossfeed later. Okay, first chips. I grabbed a hunk o' mystery steel from the bin, and I'm going to bring the cutter in close, and I'll do a little touch off with the tool head, and let's see about making some noise. Well, a little bit of noise. One thing I like about this machine is how quiet it is. Shapers are extremely civilized. It's a very calm, quiet machine. Well, until things go wrong. This was just starting to cut. I had dialed in what I thought was a 10 thou depth of cut, and it was starting to make a chip. Oh, there, first chip, second chip, and then disaster. Okay, tiny disaster, but still, that's not what's supposed to happen. So I reset it up and I tightened the vise, hopefully enough. I tightened it a lot more, and this was working. I was making some cuts, and I got most of the way across the piece, and then it grabbed it again, and that was actually worse. As you can see, it managed to push the entire vise off of the table. So yeah, remember that whole quarter horsepower thing? If it can push the vise off the table, it does not need a bigger motor. Up until then, it was cutting just fine, though. You can see it's making nice chips. So I just need a better vise setup, I guess. I'm going to try this other vise because I can arrange this one crossways. I can clamp it in this position, which I can't do with the other vise. And now it's pushing on the vise jaw, so surely it won't push the piece out of the vise and then snag the piece and then push the vise like it has been doing. And this was cutting actually quite well. Once again, this is what I thought was a 10 thou depth of cut. And I'm feeding manually, which is to say at the end of each cutting stroke, you advance the hand crank a little bit. You have basically until the end of one forward stroke to the beginning of the next forward stroke to advance however much you want to. So there's a little bit of a rhythm you get into with the machine. You can advance it while it's on the backstroke because that's what the clapper box is for. You just can't crossfeed while it's cutting. That would be bad. As I was getting towards the end, it occurred to me, you know, that depth of cut looks like more than 10 thousandths. So I paused and took a look at it. Wait for the genuine reaction here. Hey, Editor Quinn, we're going to need an instant replay on that facial expression. Yeah, that's about a 60 thousandths depth of cut, not 10 thousandths. Apparently I don't know how to read a hand wheel on a shaper downfeed. I don't know why I thought that was 10 and it's clearly 60. So that explains why there was so much force on my previous vise setup. And also, I'm impressed with this machine. 60 thou depth of cut, and it's honestly not even flinching. Like, shaper don't care. Vise in the way? Shaper don't care. 60 thou depth of cut? Shaper don't care. What speed are you running? Shaper don't care. Imagine a half horsepower on this thing. With a quarter horsepower and loose belts, it's already throwing vices across the room. Speaking of which, setting surface speed for a shaper is actually pretty weird because it's a function of both the length of the stroke and also the motor RPM, because the ram is moving one stroke per rotation of the bull gear regardless of the length of the stroke. So if the stroke is longer, the ram is moving faster. There's a chart in the manual that explains how to combine those variables to figure out what your surface speed is. But this is not a how to run a shaper video. If you want a video about how to run a shaper, let me know. I can put one together. But I'm just making chips here and exploring the machine. So after that first rough and cut, now I come in with this tool, which is a finishing tool. It's a very flat bottom tool, very wide. The idea with this tool is you take a very, very shallow cut, just 1 or 2 thousandths, and you advance it very quickly. I'm doing a full quarter turn on the feed handle between strokes on this. Again, I don't know anything about running shapers. Everything I'm saying is just what I've learned from watching other YouTubers who have shapers. So everything I know about shapers I learned from Adam Booth. So I hope I'm saying the right things here. I think I'm starting to get the hang of it though, because this finishing tool is cutting very, very nicely. No drama, it's taking really nice, smooth, wide shavings off of that part. For my first ever cut, the surface finish on that is pretty good. It's smooth to the touch. It doesn't look shiny or anything, but it's smooth. I'd call it like a 7 out of 10. It's not going to reflect any numbers on a scale or anything, but it is smooth to the touch and it's got that distinctive striated shaper look. But for a total of 1 hour of experience running this entire genre of machine, I'm going to take the W. Wow, we've got some projects to do on this machine and I have a lot to learn about it, but it's making chips and it's making noise, and that's pretty exciting. I'm excited to have this thing. I can't wait to see what it can do and find ways to work it into my projects. I hope you're enjoying it. I hope you're going to enjoy seeing this thing on my channel, because you will see it a lot in upcoming projects. Thank you so much for watching. Thanks to my patrons for making all this happen, and I'll see you next time.